Even though after reading this question, it only requires two answers, there's actually four parts. The first is very straightforward, finding the moment of inertia. But part B involves several parts. So let's get part A out of the way first. A asks us to find the moment of inertia of the grinding wheel, which is a uniform cylinder. So the equation for a uniform cylinder for the moment of inertia is 1/2 mr squared. So putting in the values that we have, 1/2 times 0.58 times 0.085, changing the centimeters to meters squared, equals 0.0021 kilogram meters squared. So there's our first answer. Now in part B, we have to do several things. We first have to find the frictional force that causes it to decelerate from 1500 to 0 in 55 seconds. So the first part of part B is to list what we know. So initially, we have omega O as 1500 revolutions per minute. We know that omega will be 0 and T will be 55 seconds. Well, okay, so we have to change this first. One revolution is 2 pi radians. And there in 1 minute, there are 60 seconds. So if we multiply that all out, we get 157 radians per second. So we have an initial velocity, a final velocity, and a time, so we can find the acceleration. So finding the acceleration, we can use omega equals omega O plus alpha t. Omega is 0, omega O is 157, plus 55, which is the time, times alpha. And we solve that for alpha. And alpha will come out to be negative 2.85. That is, it's decelerating by 2.85 radians per second squared. So that's got to translate into a frictional torque. So our frictional torque, which we call T sub F, will equal I times alpha. So I was 0.0021 and alpha is minus 2.85. So if we multiply that out, we will get a frictional torque of 0.0060. And that's part of our next answer. So now let's get to another slide so that we can get a little bit more room here. We'll come back to those two numbers in a minute. So now we have to find out how fast it accelerates from rest to 1500 in 5 seconds. So here, omega O is going to be 0. Omega will be just the opposite it was a moment ago. It'll be 157. But this time the T is only 5 seconds. So we have to find alpha for this. Again, we'll use the same equation. Omega equals omega O plus alpha t. 157, that's going to be 0, equals 5 times alpha, and alpha will equal 31.4 radians per second squared. And finally, we can find the total torque. So we have our torque that's accelerating, we'll call that TA, minus the frictional torque, which is going to be slowing it down, equals I times alpha. So we're looking for TA, and that means our frictional force torque was 0.0060 equals 0.0021 times our new acceleration of 31.4. So So remember where all these numbers came from. We just calculated that. That's our frictional torque. This is our moment inertia, which we found in I, and this is our acceleration from rest to 1500. So if we solve that for t, our accelerating torque, we will get the accelerating torque equals 0.060. And that is our final answer for part B.